All right, there. We're ready for stage 2 here, where we're going to actually write the script that'll make the wings flap. And it's not a very complicated script. So first things first, I want to put my grasshopper in kind of like a side angle like this view. And then I also want to select my main camera and press and hold Control, Shift, and F to put the camera into a view like that on my grasshopper. So real quick, let's take a look at these rotators. This first rotator, look at its rotation angles. And the second rotator, look at its rotation angles. And the third rotator, and the fourth rotator. And what we're going to notice here, for each of these rotators, they have a very different Z rotation. All four of them have a different value in rotation in Z. But for each of these wings, I don't want them to rotate more than 30 degrees up from this starting position or 30 degrees below that starting position. I want to keep the flapping limited between those degrees. So I need to have my script handle this case. Script. We're going to need a script. So let's go ahead and in our scripts folder, and there it is. Let's give it a new name here for yours. We're going to create a script, a C# script. Immediately name it flap wing. There we go. Flap wing. Gives me a brand new script. See, that's the one that I built that actually makes it happen. But I want you guys to see this come together. So with this flap wing script, I want to take it before I write any code in it at all. I want to apply this script to each of those wing rotators. So the right wing rotator gets that script, and I'll put it on the right front, and I'll put it on the left rear, and I'll put it on the left front. And I can select each of these and I can verify that they all have a flap wing script on it. So they've all got the script applied to them. Now that I've got the script applied to them, I'll double click flap wing and I'll tell Visual Studio to open this thing up so I can add code to it. Now, we are going to need the start method and we're going to need the update method. But before we get to those methods, we have to set up one public variable and we're also going to set up some variables. Now, in the public variable department, we're going to have a public float that we're going to call flapping speed. I want to be able to change that value publicly. This will let us create different flapping effects. But then we're going to need some private variables that we're going to be handling every single frame. And our first private will be a float called X rotation. And private float called Y rotation, and a private float called Z rotation. And we're also going to need two other floats. One of them is called minimum rotation. And let's see, you think you can guess what the other one would be? Yes, you're right. Maximum rotation. That sets up all of our variables. Now in the start method, we need to get some information. Remember, the start method gets called once when the script comes to life. The script goes active before the first frame is put up on the screen. Start is called. Start is a place where we set things up. We get some initial values and we set some information. So what we're going to do here is we're going to go ahead and get our X rotation. And that is going to be equal to This is getting the transform that this script is attached to. Its local rotation dot Euler angles dot x. That's going to get the x value for my x rotation. Then I'm going to copy this line of code and recycle it twice. And what am I doing here? I'm getting my initial rotation values. So I don't just want it for x, I also want it for y and z. And I want it for y and z. And that let me recycle that code. So now I've got my x rotation. It's going to pick up my Euler angles for x. Y rotation will pick up my Euler angles for y. And z rotation will pick up my Euler angles for z. Groovy. Then I'll come down here and I'm going to set my limits. Those other private variables. My minimum rotation will be equal to my z rotation minus 30.0f. Later, I might take that 30 out and change it to something else, maybe even a public variable that'll let me dynamically modify the angles that I want to set for the limitation of the rotation. I'm already making some improvements to my code. Maximum rotation is also going to be equal to the z rotation, but in this case, I'm going to be adding 30.0f. Let me take out those unnecessary extra spaces. And we are just about halfway through with all this. So here we're picking up all of our initial, right at the very beginning in the start method. This is getting the x, y, and z rotation from the transform that the script is attached to. And then it's going to be setting, for that specific instance of the script, setting the minimum rotation and the maximum rotation that apply to that transform. Then we're going to use that information in order to set the rotation in motion in update and to test for when we hit limits. So first thing we're going to need to do in update is make some space. And then we're going to make a comment here, and we are going to increase. I didn't spell increase correctly. CREA. Increase slash decrease flapping speed. And this will be z rotation plus equals flapping speed. Then we are going to, that's going to change the angle of the z rotation. And then at the end of the update, we're going to move the wing to that position. But before we move the wing to that position, we need to make sure that we have not ran into any of our limits, either our upper limit or our lower limit. So we're going to be checking to see if we have there we go. Check to see if you have hit the upper or lower limits of z rotation. Now that, of course, is going to involve an if. And if my z rotation is greater than maximum rotation, and this is important too. While our z rotation is moving towards maximum rotation, our flapping speed has been a positive number. It's been a positive number. So that means that flapping speed is going to be greater than 0. And if we've hit our upper limit and our flapping speed is greater than 0, we need to change our flapping speed. So we also need to set our z rotation to a number that's going to be okay. So we'll set our z rotation to um, maximum rotation minus 0.1 f. And so set the z rotation to an acceptable value, and we change our flapping direction. Change our flapping direction. Changing our flapping direction would be as simple as writing flapping multiply equals -1. What that does is, going in, our flapping speed was positive. If we multiply a positive number by -1, now flapping speed will be negative. When we come back around on our z rotation and we add a negative number to our z rotation, we're going to start decreasing our z rotation. Now, following this, if we're going to have an else if. And in the else if, I'm going to go ahead and copy all of this stuff that's right in here and modify it because it's got everything I want. If the z rotation is less than minimum rotation and flapping speed is less than 0. So now this is saying that, okay, my z rotation has hit a value that is lower than my minimum rotation. And currently my flapping speed is subtracting. So I need to then set my z rotation, to my minimum rotation plus 0.1 f. And again, I need to multiply my flapping speed by -1. That will change that negative number. When it's multiplied by a negative number, it will change it back into a positive number. And now my flapping speed will be adding a positive Euler angle to my rotation, and I'll be rotating back up. And so now that I've made sure that I'm either at the upper or lower, the last thing I got to do, and this is going to wrap up the script, is going to be to set the position of the wing. And that will be transform dot local rotation equals quaternion, dot Euler, quaternion dot Euler, and we're going to be using our x rotation, y rotation, and z rotation. That wraps up that script. It wraps it up. I'm going to go ahead and click save right here. Click save on that, and I'll come back to Unity. Unity will catch up with me. It'll realize that I've made some changes to this thing, and I'll go ahead and save my scene. Now, I'm going to be really disappointed because watch. I did all that work, and I'm going to press my play button, and nothing is going to happen. My wings are not moving. But that's because I didn't set my public variables value. Right now, the flapping speed is 0. And with a speed of 0, we're not going anywhere. So let's set that for the right side. Let's set that to, well, let's just experiment here. Let's just set them all to 1, and let's see what happens. Okay? If I give them all a flapping speed of 1, what's going to happen? So I set all their flapping speeds for all of mine. I set them to 1. Let's see what happens. All right, that's not the effect that I want. So I guess I should just pick a side. I'll pick the right side, and I'll set it to -1 for the flapping speed. And now when I click on the play button, my wings are flapping just like I want them to. And that's all there is to it. Thanks again to my 9th grade student, Alexandra Figueroa, for this beautiful model that she gave me to play with and giving me the opportunity to force myself to learn some more new stuff. Such a cool model. I'm looking forward to the fun I'm going to have with this thing. Don't forget to like and subscribe. Thanks now.